Hey guys, here's our lesson for 10-2. We're going to identify numbers as rational or irrational. What does that mean exactly? Rational number would include anything if we change it to a decimal and the decimal terminates or ends, or the decimal repeats, then it's rational, okay? In fact, the word rational has the word ratio in it, and ratio is another word for fraction. So when I talk about changing things into decimals, the dictionary definition would be fractions. However, turning percents and square roots and different things into fractions is not as easy as turning things into decimals. So that's why we choose decimals. All right, so terminating or repeating decimals. All right, any fraction, guys, any fraction, to know that a fraction is rational, there's no fractions at 8th grade level that are going to be irrational. So if you see a fraction, it is rational, because that's the very definition of rational if you look it up in the dictionary. Okay, so any fraction. All right, now here's why I say to be careful down here at the bottom. So if I could, we'll scroll down. And I'll zoom in. If I take a fraction like 22 over 39, okay, without ever putting it in the calculator, just because it's a fraction, I already know it's rational. I don't even have to find out what the decimal is. All fractions are rational. However, if you do put it into the calculator, okay, 22 divided by 39, the answer fills the screen and you barely see where it starts to repeat. 5, 6, 4, 1, 0, 2, 5, 6, 4, 1. You just don't see enough place values to realize that it repeats. So a fraction like that makes you think, oh, this is just a group of random numbers of decimals that fill my screen, so that, you're going to learn in a few minutes is irrational. And I just want to point out that every fraction is rational. Every fraction. No matter what the decimal looks like, every fraction is rational. Okay. Coming back up here, terminating decimals. Terminate means to end. So any decimal that does not have any dots, even if it's a long one, 7.564889, if it does not have it's considered a terminating decimal. Okay, unless it was rounded to be that way, but it's terminating. Repeating decimals, you've seen these lots. Okay, again, either with the repeater bar or 3 copies of what repeats and a . Okay, so repeat after me. Repeating is rational. Repeating is rational. Percents. All percents are rational. Okay? Now, when we get into square and cube roots, it depends. And again, you're not going to look at a square root or a cube root and just automatically know whether it's rational or irrational. What makes a square root or a cube root rational is when you type it into the calculator, how does the answer come out? Okay? If you get a whole number, like the cube root of 64 is 4, that's rational. Why? Because 4, the answer is rational. Square root of 2.25, that comes out as a decimal, but it comes out as a terminating decimal. And we've agreed that terminating decimals are rational. Okay? So anytime you put a root, cube or square, into your calculator and the answer does not fill your screen, it's a whole number or a short decimal, that's rational. Okay? So let's talk about what irrational looks like. Irrational numbers, when we change them into decimals, they don't repeat, and they don't end. They fill your calculator screen, okay? So here's what you need to remember, because most of the numbers we deal with are rational. We don't deal with a lot of numbers that are irrational. So what you need to remember is pi. Pi is the ultimate irrational number. And square roots that don't come out nicely. They're decimals that don't repeat and go on forever. Okay? So the cube root of 75 equals 4.21716. Okay, there's our 6 decimal places after the decimal point. That indicates to us that it filled my screen. I didn't write out all the place values, but it filled my screen. So that tells me that that's an irrational root. Okay, unlike the root we did on the previous page, which had a nice pretty answer in my calculator. Same thing with the square root of 60. Okay, that answer filled my screen. 7.745966692. I wrote out more place values because something I want you to see. Some students see a number or a digit repeat itself and are like, oh, but there's repeating there. Yes, but that's a coincidence that those 3 numbers happen to follow one another, and the rest of the decimal doesn't do that. Okay, so don't look at something like that and think, oh, it's repeating. It's not. Okay, then we'll try to trick you with some number patterns. Okay, the first one doesn't have a number pattern in it. Okay, so this is just if you see a decimal that has ... at the end, and careful, check to see if it's repeating, because repeating is rational. Okay, I don't see 3 copies of the same number in this decimal right in a row. Okay, so that's why this one is irrational. Completely random numbers followed by ... The next one has a pattern to it. 1 1. I'm going to use the highlighter so you can see it. 1 1, 21, 31, 41, 51, 61, 71. Well, it has a pattern. Okay, pattern does not mean anything. It's there to trick you. Okay, the only pattern that means something is a repeat. Okay, where I have 3 copies of the same number in a row. And I don't have that here. I have a pattern. It's not a repeating pattern. The last one also tricking you. 1, 2 2s, 3 3s, 4 4s, 5 5s, 6 6s. Pattern? Yes. Is it a pattern that repeats? We don't see any evidence of that. Okay, so pattern does not mean rational. Pattern doesn't mean anything. Okay, so just keep in mind that the only decimals that have ... that are rational are the ones that repeat. Let's go back and look at that on the previous screen for a second. Repeating decimals. I'm going to zoom in right down here. Okay, right here. So the ... at the end of this decimal, okay, that means the decimal goes on and on forever, but then I see 1, 2, 3 copies. That's a repeating decimal. Repeating is rational. Any other pattern or no pattern at all, irrational. All right, guys, thanks for watching. Have a good day.